These days, almost every single person in this world using gadgets in their daily lives, especially mobile phones. We are hugely dependent on this gadget. We take it everywhere we go, spend almost of our time using it. But this device don't last long. It depends on its battery life for us to keep using it. We use wired cable to charge the battery. Problem arises as the wire keeps tangling, create a mess, tend to break off, or we forgot to bring it everywhere we go. No cable, no charging. Thus, wireless charging was introduced. Wireless charging is actually an ancient technology, but it wasn't so popular back then. Until a few years back, inventors and engineers applied this technology on mobile phones, and it becomes more and more popular. It is very reliable. We don't need cable. We just take our wireless power bank everywhere we go.
There are many types of wireless charging, which is inductive charging, resonance charging, and radio charging. In this video, we will focus on induction charging, which is used in mobile phones. But how does it work? When Michael Faraday discovered about electromagnetism, he found when a copper wire is coiled, the magnetic field is stronger. He believes if electrical charge can produce magnetic field, then magnetic field should be able to create an electrical charge. Thus, he found electromagnetic induction. Let us talk about the basic of electromagnetic induction. Say that we have a copper wire coil connected to a galvanometer and a magnet. When the magnet is moving towards the coil, the pointer on galvanometer will be deflected. This is because a current is produced by the relative motion of coil and the magnet, which is known as induced current. It is said to be set up by an induced electromotive force. There is no current produced in a static condition. The magnet and the coil needs to be moving towards each other relatively and produce a phenomenon called electromagnetic induction. In this animated experiment, we will demonstrate how wireless charging actually works. So we have a light bulb, receiver coil, transmitter coil, electronic ballast, and power supply. Electronic ballast is used to feed alternating current to the coil. When the coil is powered by electricity, it creates an alternating electromagnetic field. As receiver coil moves closer to transmitter coil within magnetic flux, transmitter coil will induce electrical charge in receiver coil and produce electricity that light up the bulb. As it moves closer, the light becomes brighter. The more the number of coil, the stronger magnetic field and more current is induced. Now let's take a closer look on wireless charging in mobile phones. Mobile phone that is capable for wireless charging has a built-in receiver coil, and the charger has a built-in transmitter coil. When electricity is applied to the transmitter coil in the charging dock, it produces an alternating electromagnetic field. The alternating magnetic field is then picked up by the receiving coil and the current is induced. The AC power is passed through power rectifier and stabilized. It is then converted into DC power the phone can use to charge the battery. And that is how wireless charging works in mobile phones. Technology has done many good to mankind. It evolves better and better day by day. Electromagnetism was really a great discovery and has helped us in many ways possible. Today's wireless charging is great, but it has a lot of limitations. In fact, we still use cable for the charging dock. But who knows, in the future, we may charge our devices in a long distance. It may took a lot of time, a lot of patience, and passion for that to happen, but it might be possible, as nothing is impossible.